Okay, cool. Okay, we can start. So thank you for being patient and for waiting. We can now start with the talk. Okay, so the first thing I want from you is to take a look at this address. So this address is actually a smart contract address. What I want from you is to try to analyze it, see maybe if you see something unusual or strange. Spoiler alert, this address is the address of a unit token on Ethereum mainnet, so the token from Uniswap, right? So if you take a deeper look, we can see that this contract starts and ends with the same sequence of characters. So 1F984 at the beginning and 1F984 at the very end. So we all know that Uniswap is like their branding is around unicorns, everything's pink, blah blah. So you probably know that each emoji on your little smartphone has its own Unicode. And 1F984 is actually a Unicode for unicorn emoji. So we can interpret this address of a unit token on Ethereum mainnet as this address. It starts and ends with unicorn. So Uniswap guys cleverly embedded their logo into their own into the address of their own token. If you're curious how you can do the same thing, this talk is all about this stuff. Okay, so my name is Andrej. I've been in this space for a while. I've been to several conferences, watched dozens of talks, both in person and online, and I'm extremely grateful and thankful to be part of the first ever Ethereum conference in Belgrade, in my own country. So everything started with this tweet. Basically, I wanted to create something new, some brand new talk, purely for builders with zero shilling, just as a gratitude and to say thank you to all of those previous builders who created dozens of quality talks, which helped me to be a better developer, which helped me to be a better engineer, to understand this space even better. And decision came to vanity addresses. So it's going to be that tiny little thing which you can do in Solidity or in Ethereum mainnet. Okay, so why vanity addresses in the first place? First of all, a lot of contracts, a lot of protocols actually want to have a same contract address on all different chains. If you have like a cross-chain protocol, for various different reasons, that's a good idea to have like a same contract address on all different chains, right? So Uniswap does that, a lot of other protocols does that. Second one, what we saw on previous slides, branding purposes. You can embed something from your brand into smart contract address, whether that's like an emoji or some clever word, like, I don't know, dad or coffee or whatever can be interpreted with hex numbers and characters that we can read. It's a good candidate to be part of your address. Then reducing gas cost. So this is actually really common, especially in the MEV world. They tend to deploy contracts with a bunch of leading zeros, because when you interact with contract with a bunch of leading zeros, that can actually cost less gas. Because when you have in a call data, zeros cost less than non-zero values. And when you combine multiple zeros, it can reduce your gas cost slightly. And finally, Easter eggs, dev prestige. Finding vanity addresses is extremely heavy process, so devs tends to brag how they're good because they mined that specific address. Okay, so first of all, same contract address on multiple chains. It's useful for several reasons. UI development. You will make the life of your front-end team easier if your smart contract address is the same on all of these different chains, because they need to handle multiple things. When you connect with your wallet and you switch from chain to chain, they will need to switch also the addresses. Maybe if it's L2, maybe ABI will slightly change because of some L2 checks, etc. So there is like a room for error. When you have like same smart contract address, it's easier for them. Also, it's easier for anyone else that wants to build on top of your protocol, because they can put this address as a immutable variable or constant, and they know that it's the same on all different chains. And then your marketing team can tweet something like this: my awesome project X is available in this address on Ethereum, Arbitrum, Optimism, Polygon, all of this stuff. By the way, the address you're seeing now is the address of a deposit contract for like merging purposes. Okay, so how to do this? When we are deploying smart contract, it uses create opcode. So when you even like when you're in Remix and you have like connected your MetaMask and hit that orange deploy button, it will use create opcode. When you put mnemonic or private key in your .env file and run deployment script, it will use create opcode, right? And create opcode calculates the address of to-be deployed contract as rightmost 20 bytes of catch-256 hash of deployer address and deployer nonce. So deployer address is, the address of EOI who tries to deploy a smart contract, and it's always the same, right? When you create a new Ethereum account, your address is unique, and that's it. So what you can do is tweak the nonce parameter. So do we know what nonce is? Yeah. Yeah? Okay. Cool. So nonce stands for number only once to prevent replay attacks, etc. So, does anyone have an idea now how we can have the same address on multiple chains using the regular deployment way? We create opcode. Yeah. So, what we can do is basically, if we want our address to be the same of all different chains and we doesn't care how that address looks like, we can create a fresh new externally owned account. The nonce will be 0, right? We'll fund it with some coins, like predefined coin value of coins for gas purposes, and run the deployment script on all of different chains. So I'll run the deployment script on Ethereum mainnet, on Polygon, on Arbitrum, Optimism, etc. And because the address of my deployer account is whatever, and nonce is 0 because that's my first account, the address will be the same because it's going to be rightmost 20 bytes of catch-256 of my address and 0 because that's my nonce. It's a fresh new account. And Ether.js even has this tiny function, get from utils package get contract address, which can calculate you the address of smart contract before you deploy it, if you are going to deploy it in the next transaction, so you know the nonce upfront. So if we take this deployer address, this is actually the address of Vitalik's wallet, and if its nonce is 0, then we can calculate how would the contract address, if Vitalik did it as his first transaction, will look like. Okay, this is cool, right? Easy to do, but it's not very sustainable. And why? So this solution, as stated at this slide, is a bit naively solution, because it relies on the fact that the new account's nonce is synced across all chains. So what if we have some transaction in the middle? What if our deployment script fails? Then we'll have like a failed transaction, but the nonce will increase, right? Because our nonces are now not in synced, the address on next chain will not be the same as the contract address on all previous chains, which we don't want. So obviously we can do better. There is something called create2 opcode. So it's like for regular deployments we use create opcode, but there is a possibility to use create2 opcode, which essentially pre-computes the address of your smart contract before deployment. And create2 opcode works a bit different than create opcode. So what you can see on this slide is that contract address is computed as, again, rightmost 20 bytes of catch-256 of some other parameters. First of all, FF. This is just a constant to prevent collision from when we are doing with create opcode. So just a constant, nothing we can do really about it. Again, deployer's address. Fourth thing is actually to be deployed contracts init code hash. And the third thing is, I intentionally put it as the last step at this slide, is something called salt. So salt is an arbitrary value provided by deployer. So FF, obviously a constant, nothing we can do about it. Deployer's smart contract, deployer's EOI address, nothing we can do about it. We can maybe change the deployer address, but eventually that's going to be a constant. And to be deployed contracts init code hash, well, that's also, there's no much thing that we can do about it either, because it's like a product of our Solidity code, right? And we don't want to compromise security. So what we can tweak is actually this salt parameter, right? So to find all of these fancy addresses, there is something, there is a technique called salt mining, and we're going to tackle it later. But another important thing is that we're dealing with create2. In most of the cases, you're not going to deploy it using externally owned account. You're going to deploy it using another smart contract, because that factory contract can actually trigger create2 opcode under the hood. So you can have a view function which does exactly what we saw on the previous slide. It calculates the address of to be deployed smart contract. So you can see that we are providing init code as function argument and salt. So what you can do is maybe you can tweak that salt to find the perfect address. Okay, which create2 factory to use? There are a bunch of options, which you can see at the following slide. So create2 deployer. There's something called deterministic deployment proxy from Zoltu, and another one for Arachnid. That third one is actually using in Foundry under the hood. So if you take a look at this syntax over there, like foo equals new foo and these parentheses with salt, that syntax actually using create2 factory by Arachnid, which is like a third URL over here, and the fourth one is just OpenZeppelin's implementation, right? So the TLDR from this slide is that you can do this without knowing what create2 factory is, without developing that contract. You can just do it from Foundry, for example, with this tiny syntax, right? So salt mining. The important thing in finding those addresses is actually finding a salt value. So this is where devs tends to brag between each other, because this process is sometimes extremely heavy. So I think like one of the best repos for doing that is from Zero Age. He's like one of the main devs behind the Seaport protocol, and the repo is called create2 crunch. It's mainly written in Rust, and there's some tiny Python code snippet. But basically, when you git clone create2 crunch and start the command, first of all, your laptop is gonna be extremely starting to pronounce like wild noises, maybe to get hit, etc. But it will try to mine you efficient addresses. What I mean by efficient, it will try to mine you addresses, salts for addresses that start with leading zeros. Second option, it's present in Foundry. So Foundry has this tiny CLI command, cast create2, actually cast command. So this command, using this command, you can also mine salts for various different addresses. Okay, how does it do? So example number one, you can see the address of 1-inch router. And there intentionally, it starts with 1, 2, 7 number ones, because 1 inch, 1 is part of their branding, right? So they wanted to create a smart contract that starts with couple number ones. Okay, so how you can replicate the same thing in Foundry? Well, you can run cast create2 command using dflag pass the deployer address, which will be create2 factory smart contract address. Using flag I, paste the init code hash, and there is this tiny flag says starts with 7 ones. Example number 2. This is the latest version of Seaport smart contract. It was mined using create2 crunch, the repo you saw on the previous slides, not by Foundry. But you can replicate the same thing running the Foundry command. This address has like 12 or 13 zeros, so finding that address takes a long time, extremely long time. If you have lucky, maybe less, but you know that's like a dev prestige, because they have an address with so many zeros, and interacting with Seaport is going to be cheaper for regular users, because this address is going to be part of cold data, and a bunch of leading zeros will cost less gas. Okay, example number 3, our famous unitoken address from the beginning. So what you can, like, it starts and ends with unicorn emoji. So the same thing what you can do is in Foundry with cast create to command, it has flag starts with and ends with. So when running this command, you should be able to find a similar address, actually the address which starts and ends with the same pattern. Okay, but this is all theory, let's do it now in practice. Okay, I have one like really dummy smart contract. Most of their parts is like written by GitHub Copilot, but it's like a contract for donations, you know, like buy me a coffee contract, which can only receive native coins and only beneficiary address can withdraw the money from the contract, right? Our job for today is to find a smart contract address which will end with C0FFEE, with something that we can read as a humans as coffee, right? So that's our goal for today's. We have this smart contract, so what we can do is that we can calculate init code hash, and we'll see about the deployer what we can do. So this is what we want to accomplish in our test. So this is like a simple dummy test written in Foundry. Some setup is over there, and what we want is actually in this test deployment address function is to console log the address of a to be deployed smart contract, and to see that actually indeed ends with word coffee or C0FFEE. Setup is pretty basic, so we have one beneficiary address, like completely default one. We have salt, which is currently set to 0, so we need to mine that salt. And finally, we have this syntax you already saw from Foundry with those parentheses, salt equals salt. Okay. What you can actually do now is that you can calculate init code hash. So init code hash can be calculated in multiple ways. This one is in Foundry because everything is Solidity. You can get creation code. Okay, by doing the bytes memory equals creation code, blah, blah, from the first line. Okay. If your smart contract doesn't have any constructor arguments, you will just hash that value. That's your init code hash. But I intentionally set beneficiary address to be part of constructor, because init code hash then will depend on input values. So init code now is like we need to ABI encode the regular creation code and the beneficiary address, which is like a constructor argument, right? And then we're going to hash everything using, of course, Keccak256 hash, because that's the official hashing algorithm on Ethereum, right? That's how we found the init code hash. Now we need create to deployer address. Because on a previous slide you saw that you can use that default syntax from Foundry with parentheses, you can go to their official documentation and find that, at least in local, the create to deployer on Anvil node, the create to deployer address is that one present at the very top of the file. So that's just the address of their create to deployer contract, again using a deployment proxy from Arachnid. And that's it. That's like your constant. Now what we need to do is actually to run this command. So cast create to -d is a flag for deployer. We literally copy-pasted the create to deployer from command above, like from Foundry. Then that's our init code hash. So we calculated this value from our previous function, get creation code, encode arguments, and then hash it. And finally, it should end with coffee or C0FFEE. Okay, I run this command on my own laptop, and in 12 seconds, it was able to mine me the address you see here. So it's 0x3A0 something, but it ends with a sequence I wanted, C0FFEE. And this is the salt which will produce this address combining init code hash and deployer address. So if I want to do this on a local Anvil node in Foundry, these are the parameters I need to provide. Okay. The difference between cast command, cast create to command from Foundry and that create to crunch from zero age is that Foundry will literally stop when it's find the first address, while create to crunch is going to run maybe infinitely if you want, because it will provide you a bunch of options, and then you can literally choose salt for various different addresses if you like those addresses better. Okay. So that's pretty much it. We're on time. We had 20 minutes for this talk. We have some questions. Time for some questions if you have it from the audience. I hope you like that. I hope you like this talk. If you love it, we can grab a cup of coffee afterwards. But please don't mix salt with sugar. Thank you. Just wait for the mic.
Thanks, Andrej. Question, so on your laptop, it took 12 seconds to find salt for address with 6 characters. So how long do you think it took for Optimism smart contract address, which is ridiculously vanity? How did they generate it? I don't think it was...
It doesn't... how to call it that? It's not related to the blockchain you want to deploy it, because these 12 seconds are related to the power of my machine. So it's going to be the same thing for Ethereum, Optimism.
No, I got it, but the Optimism smart contract address is 0x42000042. So to mine salt for that one on, I don't know what machine you have to have. I think it's, how do they manage to do that?
What I know is that Zero Age used for Seaport at least, they spin up the AWS instance. I think there's like a thread on his Twitter, and say about the parameters machines, and that's how I did it. However, I don't think they're present on Optimism. So it really depends for other different chains. It really depends about the opcode itself. Like, is it compatible? If it's create to opcode, like it's gonna be the same. But again, it's really like if you want to have another chain which has like different opcodes under the hood, it's not gonna be the same process, obviously.
I'm not talking. No, it wasn't about different chains. So in Ethereum, the Optimism smart contract deployed in Ethereum mainnet, it has a like really super ridiculously vanity address.
Okay.
Which is, I think.
Okay. How they did it?
Yeah.
We can ask them. I don't know. Like,
don't know.
This is how you can do it using Foundry. You can spin up like AWS instance. You can use create to crunch. I'm not sure like what they did. Again, this is like part of devs being devs, and like devs prestige. I'm not part of that team, so I can know that. Okay, I understood the question now. This is like a general, like obviously when Uniswap deployed the Uni token, create to opcode wasn't part of Ethereum yet, I think. So they used this different mechanism, obviously. But now you can do it using something like this. Hope that answers your question. Anything else? Yeah, over there.
Hello, thank you for the nice presentation.
You're
This is very interesting, but I have one question. So, doesn't something stops me from generating my address that starts with unicorn and ends with unicorn?
No, because probably not going to be the same as Unitokens one. But if it's,
yeah, it's
you can do it if you
yeah.
want. Yeah.
Okay, thank you.
You're welcome. Yeah, another one, yeah.
Test. Okay. I guess this is a very brute force approach, right?
Yeah, it is.
So have you thought about if there's any analytics that would help you guess the salt and
I don't think
speed up
there
the
are
process?
at the moment. It's literally a brute force where you like switch salt is until you find the desired pattern. That's it. Okay.
Prova. No?
Thank you very much.